Hi, in this video we're going to be doing another example of titration, and this time we're going to be titrating a weak base with a strong acid. Our weak base is going to be NH3 and our strong acid is going to be HCl. So what is the initial pH before we added any HCl? So it says we start off with 0.0050 molar of NH3. Alright, so we can do a right chart, RICE, and we're going to have NH3 plus H2O forming NH4 plus OH minus. It would be 0.05, it would be 0 minus X, 0.05 minus X plus X plus X, X, and X. So the Ka for NH4 plus is 5.6 times 10 to the negative 10th. And we're going to be using Kb because we're producing H minus. So what is it again? 5.6 times 10 to the negative 10th. So this will be 1.0 times 10 to the negative 14, 5.6 times 10 to the negative 10. So let's calculate for Kb. 1.0 e to the negative 14 is on the bottom, 5.6 e to the negative 10th. Again, 1.79 times 10 to the negative 5th. We set this equal to x squared divided by 0.05. And we can remove this minus x because of how small our x is. Now multiply 1.79 times 10 to the negative 5th by 0.05, and then take the square root of that. To get x is equal to 9.45 times 10 to the negative 4th. We take 14 plus the log of this because the negative log of this will only give the POH. And our answer will be 10.98. Alright, now we start adding our strong acid. Alright. First let's calculate how much moles this is. So I'm gonna write this process over here, and then now I'll write it for the rest. Alright. We said we're given with 0.1 molar HCl. So on top is gonna be moles, on the bottom is liter. So milliliters and milliliters cancel out. 1 liter has every 1,000 milliliters is 1 liter, and liter will cancel out, leaving us with moles. So this will mean we have 10 times 0.1 divided by 1,000. It give us 0.001 moles. And it told us how many moles we have already. So we don't need to solve for that. 0.005 moles of NH3 and HCl. Because HCl is a strong acid, Cl minus itself is going to be a weak conjugate base. So we can ignore that. That's going to be spectrum. And now our new equation, our Rebecca chart will be simply NH3 plus H3O plus, no, NH3, not NH3 plus, sorry. NH3 plus H3O plus, because H plus is also H3O plus. Now this is going to form NH4 plus H2O. So 0.005 and 0.001 minus 0.001 is going to give you 0.004 and 0. Now to be 0 plus 0.001 is going to do 0.001 here. Okay, now we can use the chart. So let's see, what do we have here? We have NH3 and NH4 and no NH3. So when calculating pH, we can use NH3 plus H3O plus H2O, forming NH4 plus OH minus. Essentially, the exact same equation over here will be used. The exact same equation over here will be used to calculate the pH for all the rest of them, except for the ones when we exceed the buffer. So now we see that we produce an OH minus. So we can use the regular HH equation, right? So the regular is pH equals pK plus the log of conjugate base over acid. Since we're putting OH, we're going to be calculating for POH. So POH is equal to pKb plus the log of conjugate acid on top and the base on bottom. Now let's see. POH is equal to pKb. We found the Kb as 1.79 times 10 to the negative 5th. So let's take the negative log of that. Negative log of 1.79 e to the negative 5th give you 4.74. Actually, I'm going to give you 4.75. 4.75 plus the log of conjugate acid. NH4 plus is conjugate acid, so it's going to be 0.001 on top divided by 0.004. So 4.75 plus the log of 0.001 divided by 0.004 will give you 4.17. 4.15. And now this is POH though, so 14 minus that, we're gonna get an answer of 9.85. That is our pH. Alright, now what happens when we add 25 milliliters? 25 milliliters, let me do the conversion real quick. 25 divided by 1000 times 0.1 is going to be 0.0025, and it's going to be 0.005. I know they told us that we're at half equivalence point already, but I'm going to show you what it means to be, how we get the half equivalence, if it didn't tell you. Right. So we're going to set up our RBCA, and this time we're going to add NH3 plus our H2O plus again. Again, there is no Cl because it's spectrum ion. It's going to form NH4 plus H2O. Right now, this is going to be 0.005. This is going to be 0.0025. This is going to be 0. This is going to be 0. This is going to be minus 0.0025. So this is now gone, and this will be 0.0025. 0.005 minus 0.0025 is 0.025. Now this is also going to be plus 0.25, and it's going to be 0.0025. So when your conjugate and your normal has equal quantities, in this case the conjugate acid has equal moles to the conjugate to the base. So that way you're gonna create log of 1 because you have this divided by this, right? So you have log of 1, which is equal to 0, and this, in this case, POH is going to be equal to PKB. So what is our PKB? Our PKB is 4.75. So POH equals 4.75. So 14 minus 4.75, 14 minus 4.75 is 9.25. So our pH will be 9.25. So whenever these two numbers are equal after the regular chart, you straight up know that it is going to be at the half equivalence point where the pH equals PKB, pKa, or the POH equals PKB. Okay, now for number 4, we're going to add more. Now we have 45 milliliters. So 45 milliliters equals how many moles? 45 divided by 1000 times 0.1 is to give you 0.0045 moles compared to 0.005 moles. So our BCA is going to be a NH3 plus H3O plus, forming NH4 plus H2O. It will be 0, it will be 0.005, it's going to be 0.0045. Minus 0.0045, it's going to be 0, and it's going to be 0.0005. It's going to be 0 plus 0.0045, and it's going to be 0.0045. Okay, now we can create a POH equals PKB plus the log of what's on top, or let's conjugate acid divided by base. So, which is equal to 4.75 plus the log on top is going to be 0.0045, and on the bottom is going to be 0.0005. So 4.75 plus the log of 0.0045 divided by 0.0005 is going to give you an answer of 5.70. 5.70. Again, this is pH. This is POH. So we're gonna have to subtract 14 from it. So our answer will be 8.29, 8.30, and that's our pH. Next, HCl, 50 milliliters. All right, this is the equivalence point. So we can create our BCA, and we know that that's gonna be plus H3O plus, forming NH4 plus H2O. This is going to be 0.005, this is going to be 0.005. We're going to subtract 0.005 from both, which is going to end up with 0 and 0. This is going to be plus, this is going to be 0 over here, plus 0.005, and end up with 0.005. Now the only thing we have left is NH4 plus, so we're going to have to create a rice chart this time, and it's going to be our only product left, which is NH4 plus, added to water to find the pH, which will give you NH3 plus H3O plus. Right, before doing a rice chart, we gotta convert this 0.005 to liters, to molar, because in a rice chart we can only work with molar. So 0.005 divided by, let's see what it says, 50 milliliters over here, and in the beginning it should also be another 50. Alright, and in the beginning it's also it's 100 milliliters. It's gonna be 100 milliliters plus 50 milliliters, which is gonna be divided by 1.5 is 150 milliliters. So 0.150 liters. Again, this 50 milliliters plus 100 milliliters in the beginning. So 0.005 divided by 0.150 is gonna give you 0.0333. Now it's gonna be 0 over here, minus plus x. It's gonna be minus x, 0.0333 minus x. X. Alright, now because we have NH4 now, and we're producing H2O plus, we can use the Ka of NH4. Ka for NH4 is gonna be 5.6 times 10 to the negative 10th. So 5.6 times 10 to the negative 10th power is equal to x squared divided by 0.0333. We could delete this minus x. So 5.6 e to the negative 10th times 0.0333. Take the square root of that. It's going to give you x equals 4.32 times 10 to the negative 6. Take the negative log of that. And we'll get 5.36 as a pH. And this time we found the pH and not the pOH, so we don't have to do anything. We don't have to add 14 to it. So our answer is 5.36. Now we add 51. Alright, 51, let's convert it into moles. 51 divided by 1000 times 0.1 is going to be 0.0051 moles. So in our RBCA chart, it's going to be NH3 plus H3O plus, forming NH4 plus H2O. And this is going to be 0.005. This would be 0.0051. So we subtract both sides by the smaller one. It will be 0.005. Now our excess reactant is no longer the acid. Instead, it's the base. So this is going to be 0 over here. No, our excess reactant is going to be the acid, and our limited reactant is going to be the base. So it'll be over here, and it'll be 0.0001. And plus 0.005, it'll be 0.005. Okay, now let's do the HH equation. pOH equals 4.75 plus the log of, again, and also forgot to mention, if you used a different, so I rounded to 1.79, but the actual number is actually 1.785 something. So if you didn't round to 1.79, then you could have got PKB of 4.74 instead of 4.75. But I'm going to go with 4.75 because that's what's shown in my work. Now 4.75 plus the log of conjugate base on the top is going to be 0.00. Conjugate acid on the top is going to be 0.005. And our... Oh, shoot. No, never mind. We won't even use this equation anymore because we have an excess H3O plus. So there will be no equation because we're going to be divided by 0. There will be no HH equation because we'll be divided by 0. And we can just convert 0.001, 3 zeros, divided by our new volume. We have 51 plus the 100 in the beginning. So 51 plus 100 is going to be 151. So we're going to divide this by 0.151 liters. 0.0001 divided by 0.151 will give you 6.623 times 10 to the negative 4th molar. Now this is molar of this is concentration of H3O plus, so we can take the negative log of that, which forms a pH of 3.178, which will be 3.18. Alright, finally we have 60 milliliters. 60 milliliters is 60 divided by 1000 times 0.1. Then give you 0.006. Now our BCA, we have NH3 plus H3O plus, forming NH4 plus H2O. Right now this is going to be 0.005, this is going to be 0.006, and this honestly won't matter because we're going to be using the concentration of H3O plus anyways. And you can use this, you can just take the negative log off of the concentration of remaining H3O plus when we exceed the equivalence point. Right, when we have no more base left and only H2O plus. In the previous video where we did OH minus, that's the exact same thing we did. So now we can subtract both by 0.005, it's going to be 0 and 0.001. And we can just use this 0.001. So convert this to molar, and this can be divided by, this time 60, so it's going to be 0.160 liters. So 0.001 divided by 0.160 will give you 0.00625 molar. Take the negative log of that. Negative log of that gives you a pH equals 2.20. Alright, now let's graph of that. Alright. So let's see what we have here. We start off with 10 pH of 10, and as we add more and more HCl into it, the pH decreases, and at equivalence point we have a pH of lower than 7, which makes sense because we have a weak base and a strong acid. And let's see, initial is 10.98, so when 0 is going to be 10.9, so around here. Alright, and then when we add 10, we have 9.85, so 9.85, so around here. And then at 25, it's 9.25. 25 is 9.25. We have 45 at 8.3. 45 at 8.3. And then 50 is going to be 5.36. 5.36. And then 51 is going to be 3.18. And at 60 is going to be 2.20. So 60 is going to be 2.2 over here. And then 3.18 at 51. So over here, 3.18. No, maybe even lower. 3.18 should be around here. So our titration curve goes like this. And yeah, that is how a titration curve will look like when you're titrating a weak base with a strong acid. And that's it for this video. Thank you for watching.